I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll solve one problem by using Naïve-based classifier. So all you know that the Naïve-based classifier is a probabilistic model that predicts outcomes based on Bayes' theorem. This all you know that. It calculates the probability of an event occurring by considering prior knowledge of condition. Say, for example, if you are taking the context of weather data, the classifier determines whether to play or not by analyzing attributes such as outlook, temperature, humidity, and wind. Some other attributes are also there. Whether it is the outlook attribute plays a significant role. Taking three possible values in this case, we are going to take. What are the three values? Are sunny, rainy, and overcast. Each of these values influences the likelihood of playing, and the classifier computes the probabilities of playing or not under these conditions. Despite assuming that attributes are independent, the Naïve-based classifier performs efficiently in such classification tasks. What is the problem here? We have taken this is the problem statement, and the goal is to decide whether to play or not on a particular day based on the weather conditions. First step in this case, should the player and also should the player play if the weather is sunny? This is the problem statement. What is the problem statement we have taken as whether the player is able to play, whether should the player play if the weather is sunny? And in this case, we have to convert all the data set into the frequency table and how much, count how often each attribute values occur when play is equal to yes or play is equal to no. That will see, look into the table. And then we have to create the frequency table for attributes like outlook, sunny, rainy, and overcast. And we have to generate the likelihood table. From that, we have to find out the probability of each attribute. The given target formula is for the generalized formula is probability of xi given y is equal to frequency of x under y divided by total instant of y. And by using the Bayes theory to calculate the probability of playing or not, we have to write the formula like this. Probability of play given conditions equal to probability of condition given play, Bayes theorem says, into probability of play divided by probability of condition. This denominator value will come. So this is the table. What is the problem is, should the player play if the weather is sunny? I'll repeat the question one more time. Should the player play if the weather is, so many outlooks are there. We are going to take only one attribute. Weather condition, that is temperature condition is sunny. Should the player play if the weather condition is sunny? So determine whether the player should play or not. When the weather is sunny, the Naïve-based classifier calculates the posterior probabilities for both outcomes. That is play is equal to yes and play is equal to no using Bayes theorem. It considers the likelihood of sunny under both conditions. Both conditions it will be considering and multiplies it by prior probabilities of playing or not playing. The result with higher probability determines the final decision. If the probability of play is equal to yes is greater than no, the recommendation is to play. Otherwise, the decision is not to play. This will look into this table. So here we have taken the table. This second column represents the outlook, and it is the third column represents the play. Here the first row says rainy, yes. The second row says sunny, yes. Overcast, yes. Overcast, yes. So we have the 14 combinations. Sunny, yes. Here rainy, no. Overcast, yes. Overcast, yes. In this, first we have to find out the weather conditions. We will be taking these three parameters. Outlooks equal to sunny. From the above table, we have to consider all those parameters and we have to calculate it. So here for three parameters, this is the first parameter, second parameter and third parameter. Sunny, play is equal to yes. So from this table, how many sunnies are there? We have to consider. This is one sunny, 2, 3, 4, 5. So out of this 5, how many yes values are there? This is one yes. This is the second one. And this is third. So we have to write Sunny place equal to yes means how many values are there? 3. If place equal to no, this is no. 1 and this is 2. So we have to write it in the table. Place equal to no is equal to 2. Total Sunny is 5. So the second case is rainy. If you are considering the rainy, here this is one case and the first one 2, 1, 2, 3, 4. So how many S is there? 1, 2. How many no's are there in the rainy? So 1, here 2. So 2 values are there. So we have to consider the 2, right? So in this case, how many 2's are there? How many values are there? 2 and here 2. No is 2. Yes is equal to 2. So the total rainy values in the above table are 4. So we have written. Next to overcast. So if you are taking the overcast, so how many values are there? Overcast. The third row combined. Third row gives us one value. Third row gives one value. So here 1, 2, 3, 4, and 5. So all values are yes only. So there is no place equal to no. So it's equal to 5. So the total play yes, how many yeses are there in the above table? So if you are calculating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally how many yeses are there? 10 yeses are there. So similarly, no 4. So total if you are counting total, S is equal, S plus no is equal to 14. The next table, if you are finding out the conditions, weather conditions, probabilities if you wanted to find out whether overcast, rainy, sunny. But our problem is whether if it is a sunny, whether the player is able to play or not. That is our problem. So, but each and everything we have to find out. Overcast, no, yes 0, yes 5. So how many values are there? How many total values or the rows are there? 14. This comes under the denominator. In the numerator, 5 divided by the total values you are calculating. 5 divided by 14 is equal to 0.35 out of 14 values. So our probability of overcast is both either 0 or yes. Both no and yes. The probability is 0.35. And the rainy 2 plus 2, 4 divided by 14, 0.29. Sunny 2 plus 3, 5 divided by 14, 0.35. And here the no, for the probability of no, 4 divided by 0 plus 2 plus 2, 4 divided by 14, 0.29. And 5 plus 2 plus 3, 10 divided by 14, 0.71. And if you are calculating this value, if you are calculating the 0.29 and 0.29 and 0.71, if you are adding, we have to get the probability value is 1. Similarly, if you are adding this, you have to get the value is equal to 1. Okay. Next, we have to calculate whether it is sunny or not. We have to find out first the probability of yes given sunny. Yes given sunny. Our question is whether player is able to play. The condition is sunny. Yes given sunny. By using the base rule, we will write it as probability of sunny given yes into probability of yes divided by probability of sunny. And the probability of sunny given yes, what is the value? how many Sunny values are there? So 3. So 3 divided by total. Here yes, how many S's are there? 10. So 3 divided by, out of 10, 3 is the Sunny, the play is equal to yes. So we are writing it as 3 by 10 is equal to 0.3. And the probability of Sunny alone, here probability of Sunny alone, whether it is a no or yes, total probability is how much? 0.35. So we are writing 0.3. Probability of yes, how many S's are there? Here the probability of yes is equal to total probability of yes is equal to 0.71. So we are writing over here. So the probability of yes given Sunny is equal to 0.3 into 0.71 divided by 0.35. So we are getting the value probability of yes given Sunny is equal to 0.60. Next we have to find out probability of Sunny given no is equal to probability of no given Sunny into probability of no divided by probability of Sunny. This value should come. So probability of Sunny given no from the above table, we are Sunny is no. Here 2, right? So 2 divided by 4. How many values are there? Total no values are 4. 2 divided by 4. So we are finding out 2 divided by 4 is equal to 0.5. Probability of no. What we have found out? Probability of generally the no we found out 0. The total probability 4 divided by 14 is equal to 0.29. Next we have to find out probability of Sunny. We found out already probability of Sunny is equal to 0.5 divided by 14. We are getting 0.35. So we are getting 0.35. So hence probability of no given Sunny is equal to 0.5. That is Sunny given no into the probability of no divided by probability of Sunny. 0.5 into 0.29 divided by 0.35 is equal to 0.41. So from these two calculations, probability of yes given Sunny value is 0.60 and probability of no given Sunny is 0.41. Which value is having the highest value? Probability of yes given Sunny or probability of no given Sunny? Probability of yes given Sunny is having the greater value than that of no given Sunny, 0. So from the above calculations we are finding out and we are coming to the conclusion that the probability of yes given Sunny is greater than probability of no given Sunny. So what is the conclusion for this problem? Hence, on a sunny day, whether player is able to play or not. Now we found out the value yes is greater than here sunny variable, conditional variable. Yes value is greater than no. So what is the conclusion? And on a sunny day, player can play the game. Hope everyone understand. So one more time I'll repeat. So you have to find out player yes given Sunny. So in that we are getting 0.60 and after substituting all the values here we are getting 0.41. Probability of yes given Sunny is greater than probability of no given Sunny. Hence the on a sunny day player can play the game. I hope everyone understood this problem. It is a very simple problem. So coming into the conclusion that when the weather is sunny, the decision to play or not is based on the calculated posterior probabilities using the Naïve-based classifier. By analyzing the likelihood of sunny weather along with prior probabilities of playing and not playing, the classifier predicts the most probable outcomes, the 0.60 and we are finding out 0.41. If the probability of yes, in this case probability of yes given sunny is higher, the probability, the player, what is the conclusion? The player should play. Otherwise, the recommendation is not to play if the value is greater than that value. This approach ensures that an informed decision by considering past data and calculating the likelihood accuracies. Hope everyone understood this problem very clearly. The remaining things we'll discuss in the next lecture. Thank you.